Welcome to the stomach. So when we look at the stomach, it is kind of a J-shaped organ. So that part of the stomach is actually higher than the gastroesophageal junction. And on the right side of the stomach, you have a small curve. And on the left side of the stomach, you have a larger curve. And remember, the spleen would be sitting over about here. Okay. Looking at the mucosa of the stomach, you can see it's all wrinkled. And these wrinkles of the mucosa, these folds of the mucosa are called the rugae of the stomach. Now, this is not the only organ that's going to have rugae, but what these mucosa folds, what these rugae allow for is expansion. So think of like all these wrinkles. And as content enters the stomach, these wrinkles are allowed to flatten so that the stomach can hold more content without ripping the intercellular connections between the epithelial cells. If the mucosa was flat when it was empty, then when you ate, you'd be tugging on those intercellular connections. And all these rugae allow a normal stomach to hold an entire liter, so 2 bottles full of food and liquid. Now, if you look at the stomach on the right, you will notice that there's lots of rugae proximally, but distal, it's lost a lot of the rugae, and that's what happens as you age. And perhaps you've heard that as people age, they tend to not be able to eat as much, and this is a reason why. Looking distally, what you will notice is there is another sphincter. This sphincter is called the pyloric sphincter and is super important because it controls the emptying of the stomach. This sphincter is like the biggest sphincter in our entire body. It is about this size. Okay, so it's the size of an apricot or a small plum. It's bigger than a walnut in its shell. Okay. And basically, it's keeping the food in the stomach while the stomach is doing its work. It's churning, it's mixing, all its mechanical digestion. And then when it opens, it lets a little coffee spoon out at a time, and that's it. And another 30 or 60 seconds later, it's going to let the same amount out. Looking at the wall of the stomach, we've looked at the mucosa, but let's now look at the muscularis layer, where we still have an outer longitudinal muscle and an inner circular muscle. But because the stomach is the #1 site for mechanical digestion, we have a third muscle layer, what we call an innermost oblique muscle. So now we have muscle at the x-axis, the y-axis, and the z-axis. So when it is mixing, it's not like mixing something in a bowl with a fork, and it's not like taking out your portable little plug-in mixing machine. You have the big mixer machine with the big batters, and it is doing huge mechanical mixing, mechanical digestion going on here in the stomach. If you look at the surface of the mucosa up close, what you would notice is there are depressions, and these depressions go downward into the mucosa, and they are known as gastric pits. And below the gastric pits, we have underlying gastric glands. And most of the gastric glands are going to be in the mucosa, and some are going to go into the submucosa as well. And if you look at this gastric glands, you'll notice they've got like some of these pink cells, some of these Pac-Man cells, some of these purple cells, and some of these blue cells. So in other words, there are a lot of different type of specialized cells, and each cell secretes something different, and these cells all have specialized names. And in this course, we're not going to learn the names of the cells, and we're not going to learn all the different secretions, but we are going to learn some of the things that are secreted here in the stomach and what they do so that you understand what it is the stomach and your small intestines and your large intestines are doing. So looking first at your gastric secretions, these cells here are secreting mucus. So this is a slimy layer which is going to come out and it's going to coat the gastric pit and it's going to coat the mucosa of the stomach. So no matter what is coming in from above is going to be sitting on top of this layer of mucus. And this layer of mucus can be 1 to 2 millimeters thick. So it's quite significant. And it also means that no matter what these other cells are secreting, the mucosa cells are being protected from it because those secretions are going to be sitting on top of the mucus and not affecting those cells directly. So let's look at some of these cells in the gastric gland. So we've got lots of these purple cells, and these purple cells secrete a substance known as pepsinogen. So anytime you see a word with gen, that means for like Genesis, in the beginning, before, this means it's something that is in an inactive state. And pepsinogen is a protease that's in an inactive state. So what is a protease, you say? Well, let's look at that word protease. If you recall, ACE, A-S-E, means it's an enzyme. And so let's look at the first part of the word, P-R-O-T-E. Do you see how that is most of the word protein? So this is an enzyme that's going to be breaking down, chemically digesting proteins. Okay, so pepsinogen is an inactive enzyme that will be chemically digesting proteins. And the reason why it is inactive is because if it was active inside the cell, it would be digesting the proteins that make up the cell, which means that cell would die. So it has to be an inactive form inside the cell. So it gets secreted in an inactive form, which means it needs to be activated. And I'll show you how that happens on the next slide. But before we go there, let's look at these Pac-Man kind of cells because they secrete a couple of things. And the one that we are interested in is hydrochloric acid, HCl. So hydrochloric acid makes our gastric pH 2. In other words, really, really acidic. But that acid does something really cool. Hydrochloric acid acts on pepsinogen. So here's a pepsinogen molecule. And what it's going to do is it is going to cleave it right here. It's going to denature this protein and it's going to remove part of it. And so what is left is called pepsin, which is the active enzyme, the protease. So when you come back and you see the part where I'm talking about digestion of proteins, I'll be talking about what pepsin does later on. So if we put this all in place, here is a gastric pit and a gastric gland. We have one type of cell secreting hydrochloric acid, which works on pepsinogen, which was secreted by a different types of cell, and it converts it to pepsin, which is then going to work on a protein, and it's going to give us peptide fragments. All right, so let's talk about the functions of a stomach. And isn't this a great photo? We've got the esophagus with a stratified squamous epithelium looking really white up here, and the stomach with this simple cuboidal epithelium and its rugae looking totally different. In here, you can see that really pronounced pyloric sphincter, and you can see a little bit of the sliminess from the mucus going on. So the stomach is going to store food temporarily, whatever comes down to it from the esophagus. It's going to do mechanical digestion, and it's quite good at it. Why? Because it has 3 layers of smooth muscle, an inner circular, an outer longitudinal, and an innermost oblique layer. When it does its mechanical digestion, it's going to be forming something that is slimy and greenish and has pieces of chopped up food stuff known as chyme. As it continues that digestion, instead of looking like this type of pea soup, it can look like this type of pea soup. And with the hydrochloric acid activating the pepsinogen, we are going to be able to start protein digestion of whatever proteins were in the food stuff that while it's still in the stomach. But that hydrochloric acid giving us that low pH is going to deactivate the salivary amylase and stop the carbohydrate digestion that started while it was still in your mouth. So chew it, keep it in your mouth for 30 seconds before you swallow it, because once those potatoes hit your stomach and they get hit with the hydrochloric acid, the carbohydrate digestion is stopping in your stomach. Other stomach functions, no nutrients are going to be absorbed. Why? Because we stopped carbohydrate digestion. We're only starting protein digestion. We haven't talked anything about lipid digestion, and we haven't talked anything about nucleic acid digestion. However, what is absorbed from your stomach easily across this simple columnar epithelium is alcohol. So if you are consuming alcohol, make sure your stomach is full of food stuff, right? To slow its absorption. If you can't do food stuff, then make sure you do a mixture like a Bloody Mary. So you've got that tomato juice and maybe that celery that you're chewing. For God's sake, please do not do shots because they're going to be absorbed super quick. And don't forget, the function of the pyloric sphincter is to have very controlled, slow emptying, depending how big your meal is. The fastest is going to be is 2 hours, and it could be as long as 6 hours, Thanksgiving. And also remember, liquids are going to get processed a lot faster than solid foods. And with that, I'm done with the stomach. Come on back for our next visit, where we're going to pass through the pyloric sphincter and we're going to be in our small intestine. Thank you so much for your hard work, and I'll see you shortly.